Today what I'm going to talk about is something called the distributive property. Excuse me. And the distributive property is used for multiplication, or we use it when we are multiplying to simplify an expression. And the distributive property will give equivalent expressions, and equivalent expressions are expressions that are equal to each other. So let's take a look down here. I've got some examples of equivalent expressions. And I'm going to skip down to this one here. So if I was multiplying 3 times 4 plus 2, that's pretty much the same as saying 3 times 4 plus 3 times 2. And let's just do the math here. If I did this using the order of operations, if I did 4 plus 2, I would get 6, and 3 times 6 is 18. So over on the left-hand side, I have 18. And then if I did it using this expression, if I did 3 times 4, that would give me 12, plus 3 times 2, which is 6. So 12 plus 6 is also 18. So those are equivalent expressions. Now what I have up here is I have letters. I have A times the sum of B plus C. Well, if I'm doing A times the sum of B plus C, pretty much I have to do A times B plus A times C. So the equivalent expression would be A times B plus A times C. Same deal if I have the sum of B plus C times A. My equivalent expression would be B times A plus C times A. So that's my equivalent expression. Same deal here, except I've got numbers. 4 plus 2, all times 3, is 4 plus 3 plus 2 times 3. And as I pointed out up here, this is 18, and this is also 18. Okay, it works, the distributive property works when we have an addition or a sum. Same deal if we have a subtraction. So A times the difference of B minus C is A times B minus A times C. So there's my answer. If I have the difference before in the first part, so I have B minus C all times A. My equivalent expression would be B times A minus C times A. C times A. So that is the distributive property. Now, one way that is sort of helpful when trying to figure out, to visualize this when trying to figure out the distributive property, is doing area. So let's say that I've got this rectangle, and my rectangle is broken up into 2 parts. The first part is the width of my rectangle, I will say is 4. And the length from here to here is 5. The length from here to here is 2, okay? So to find the area of a rectangle, we have to do area equals length times width. Or, well, there's a couple ways I can do this. If I want to look at this, I can say, well, the area is the area of this rectangle, which is 4 times 5, plus the area of this smaller rectangle right here, which is 4 times 2. Another way I could do this is I could say, well, I just want to find the area of the whole rectangle, the big rectangle. So I'm going to do 4 times 5 plus 2. So 4 times 5 plus 2. And if I multiply this out, both sides, I have 4 times 5, which is 20, plus 4 times 2, which is 8. Over here, if I do 5 plus 2, I get 7, so I have 4 times 7. 20 plus 8 is 28. 4 times 7 is also 28. So there we go. Check. Either way, I get the area of the big rectangle. And this is a great example to show me two equivalent expressions to find the area of a rectangle. And also, it's a great example illustrating how the distributive property works. All right. So let's do some examples here. I think it's time to switch some colors. So I think I'll go with blue now. So if I want to do 4 times the sum of 5 plus 6, I could do, let's see, draw a little arrow here. It would be 4 times 5 plus, because I have addition right there, 4 times 6. Well, 4 times 5 is 20, plus 4 times 6 is 24, and my answer is going to be 44. Let's just double check that. What is 5 plus 6? 5 plus 6 is 11. 11 times 4 is 44. Okay, here I've got one with a variable in my sum. So to simplify this, I do 5 times x, which is 5 times x, plus, notice I've got the addition sign, plus 5 times 3. So I have 5x plus 5 times 3 is 15. And then there is my answer. I can't simplify it. I'm just going to leave it like that. Here's another one. Negative 7 times x minus negative 7 times 1. Well, negative 7 times x minus negative 7 times 1. Well, negative 7 times x is just negative 7x. Minus, what's negative 7 times 1? I have a negative and a positive. That's an odd number right there of negative sign, so my answer will be negative 7. So I have minus negative 7. And remember, subtracting is like adding the opposite of this. So the opposite of negative 7 is positive 7. And adding the opposite, my answer is just negative 7x plus 7. Okay, the final one, I have 3 times 2x plus 3 times 4. So 3 times 2x plus 3 times 4 gives me 6x plus 12, and that's my answer. Let's circle this one too. All right, let's find the area 2 ways. So here I have my rectangle. Let's say that I know that the width of it is 10, and the length is, right here is x. I don't know what that is, and this is 2. So a couple ways I can find the area. Let me change colors. First thing I'm going to do, what if I just wanted to find the area of this rectangle right here? It would be width times my length. So it would be 10 times x. And then, if I wanted to find the area of this little piece right here, in that Christmassy, I could do 10 times 2 plus 10 times 2. So what this gives me is 10x plus, whoops, not 10, plus 20. Now let's do this another way. Another way I could do this is I could say, all right, well, I just want to do the whole thing. So this length right here is x plus 2. And so it would be 10 times x plus 2. And using the distributive property that we've been working with, I do 10 times the first number, which is 10 times x, or 10x, plus 10 times 2, and 10 times 2 is 20. Look at that, we have the exact same answer. On. here I have a blank page. And so on this blank page, I was going to do some fun examples, but instead, I think I will draw a little picture of you watching the video on the distributive property. And I think probably that you, hold on a second, will have red eyes. Red eye. See, I am such an artist. Yay, the distributive property. Okay, that's enough of that. I've got some examples for you to try. I want you to give these a shot when you come. So when you come into class tomorrow, you will have. I want you to find the area 2 ways for this rectangle. So the first one, I'm going to have this be 6. This little piece right here will be 1, and I won't know what this is. So I want you to come up with equivalent expressions, or how can I find the area of the big rectangle in 2 ways. So the big rectangle. So the big rectangle. Okay? So I want you to do the equivalent expressions. The next one is just a straight algebra problem. I want you to simplify 6 times the sum of x plus 2. And the third one, same deal, -4 times the difference of x minus 5. Good luck, and I will see you tomorrow.